So in the previous session, I had stopped in this topic. So let me continue with the evaluation matrix. So the most crucial step in the creation of any machine learning model is to assess its performance. Okay. So as a result, the topic of how to evaluate the success of a machine learning model arises. How would we determine when to call it a day and stop the training and evaluation? Machine learning tasks are linked to evaluation measures. Different metrics exist for classification and regression tasks. Some measures, such as precision recall, are valuable for a variety of purposes. Supervised learning, which accounts for the vast majority of machine learning applications, include classification and regression. We should be able to increase our overall models for predictive capacity and using several metrics for performance evaluation before deploying it on an unknown data. So when a machine learning model is deployed on unseen data without performing a proper evaluation, utilizing several evaluation metrics and relying just on accuracy, it might cause a problem and result in a bad prediction. So it is trying to say that it should not be just rely upon accuracy. There are various other performance measures that are present for logistic regression problems, that is classification problems. So let's see what are the ways we can actually find out how the model actually gives a better performance based on several measures like confusion matrix. Okay, so confusion matrix, to better understand, let us take an example of COVID-19. Imagine we are creating a model to predict the COVID cases. There are two outcomes: either the person is tested positive or tested negative. But in the real world, these results are not as accurate. Sometimes the results which come out may be wrong, and situations to handle each case. So here what happens is that we have true positive. True positive means the predicted value is actually the same as the actual value. That is, let's see, these are the value that is predicted as positive when the person has COVID. So that is true positive. So the actual is positive, the person is having COVID, and actually it is predicted positive, then it's called as true positive. And true negative, these are the value that is predicted as positive. This should be negative, sorry. Okay, these are the value that is predicted as negative when the person has COVID, as it does not have COVID. Okay, so you have to change this thing. It should be these are the value that is predicted to be negative when the person does not have COVID. So predicted is negative, and actually the person does not have COVID. That is negative. That comes out to be true negative. So false positive. These are the value that is predicted as positive when the person does not have does have COVID. So this should be, you have to change this statement as well. So these are the value that is predicted as positive when the person has COVID, when the person does not have COVID. Yes, that's correct. I mean, not have COVID means negative, right? So this statement is correct. Okay, there is no problem with this statement. These are the values that is predicted as positive when the person does not have COVID. That is, person does not have COVID means negative. Okay, actually is negative and predicted as positive. Okay, here is the prediction, so it comes out to be false positive. So false negative is, these are the value that is predicted as negative. Okay, correct, when the person has COVID. Okay, correct. Okay, these are the value that is predicted as negative when the person has COVID. So this is true. Okay, so let's see the accuracy part. So accuracy here is defined as the ratio of correct prediction to total prediction. See, the correct prediction are true negative and true positive, because the prediction actual is negative, predicted is negative, true negative. Actual is positive, predicted is positive, true positive. So true negative plus true positive divided by the total number of prediction. That is true negative plus false positive plus true positive. So this is the accuracy. Misclassification. It is defined as the ratio of incorrect predictions to total prediction. Misclassification is nothing but false positive and false negative. That is, whatever you predicted is wrong. So that comes out to be misclassification divided the total prediction. Okay, false positive plus false negative by total prediction. So true positive rate. True positive rate is true positive by total number of actual positive cases. True positive this by how many positive cases is there, this. Okay, actual. So true positive plus false negative. And false positive rate is, so false positive rate is false positive is this. The predicted is positive but actual is negative. That comes out to be false positive by false positive plus false negative, I guess. False positive plus true negative, sorry, true negative. The actual is negative and predicted is positive, right? So false positive rate is false positive by false positive plus true negative. And true negative rate is similarly true negative, true negative by true negative plus how many cases? False positive. Okay, these were all the things we have discussed. Now let's come to precision. Okay, so it is a value that has been predicted as positive and how often it is correct. Okay, so we are just checking, like precision is like you have predicted positive and how often it is correct. So how many times you have predicted positive? This and this, right? How often it is correct? So for that, we have to give true positive divided by true positive plus false positive. So precision is nothing but if a person is not having or having COVID, and how many times you have predicted that a person is having COVID, then we have to take that case. Okay. So in our case, we have predicted true positive plus false positive total cases. So that is actual is true positive. That is the total number of true positive cases and divided by true positive plus false positive is our precision. And recall is like how many times you have predicted the negative cases correctly. It's like it's true negative, a person is not having COVID, and you have predicted negative cases for a person who is having COVID. Okay, a person is having COVID and you have predicted it. That is recall. So it comes out to be true negative by true negative plus false negative. So let me give the theoretical part. We use precision when wrong results could lead to loss of business. It is more useful when false positive is higher concern than false negative. Okay. When false positive negative is not a big concern than false positive, then it's a higher concern. Precision is in COVID case, it's just like you have predicted positive, but like you have predicted that a person is having COVID, but the person is not having COVID. That is false positive. And in recall, it's nothing but you have predicted that person is having COVID. Actually, the recall is nothing but a true positive but true positive plus false negative. Okay. So you have predicted that person is not having COVID, but the person is having COVID. Okay. That's the worst part, I mean, if you do the prediction where a person is having COVID and you do the prediction as not COVID, it's a problem because even if you have a person who is not COVID and if you predict it as COVID, then it's fine. I mean, but if you predict that if a person is not having COVID, if a person is having COVID and you are predicting that it has not having COVID, then actually there is a chance that he will go some places and spread the disease, right? So this is how. So we use precision when wrong results could lead to loss of business. It is more useful when false positive is higher concern than false negative in precision. Examples, email spam. If an important email is sent to spam folder and the user misses it due to the reason, it might cause a huge loss to the company. Okay, spam or not spam, if a important mail is sent to spam folder Hence, the precision is more useful in that case. Recall is useful when it is the value that tells how many actual positive cases we were able to predict correctly. How many actual positive cases? Okay, this is the positive cases we predicted correctly, and this is we cannot be able to. We didn't predict correctly, which shows a positive cases. Okay, it doesn't matter much if we detect false, but the actual positive cases should not go undetected. It is more useful when false negative is or higher concern than false positive. Example, fraud transaction. If you are evaluating or filtering fraud transaction, it is better if the predict a good transaction as fraud rather than predicting a fraud as genuine. Okay, in this case, recall works. So F1 score is nothing but a harmonic mean of precision and recall. It is a combined approximation of both precision and recall. When false positive and false negative both are important parameters for the business, then only we will use F1 score. Okay. It is precisely used to compare two classifiers. If suppose model A has higher precision and model B has higher recall, in that scenario, F1 score of models A and B is come. Okay, so before moving to ROC curve, let me go to logistic regression over here. So I'm going to repeat the confusion matrix from this PDF. So it is a performance measurement for a machine learning classification problems where output can be two or more classes. It is a table with four different combinations of predict and actual values. So see, these are the actual values. These are the predicted values. So you predict that your prediction is positive and your actual is positive, then it is true positive. So you have to understand whatever that positive here coming right and the right hand side, that is the predicted. So here you have predicted positive, it comes positive, and positive is the predicted and negative is actual, which is false, right? So we get false over here on the left hand side. So in the next case, you see the actual is positive, predicted is negative, right? Negative, and you see actual is positive and predicted is negative, which is false. So right, left, false, then left hand side. Once again, predicted is negative, that you have to write negative. So actual is negative, predicted is negative, right? True negative. Okay. So first, whatever in the right hand side looks positive, negative, you have to make sure that that should be the predicted value that comes on the right hand side. And whatever you predicted, if it is matches with the positive actual value, then if it is true or false, then you have to write true or false on the left hand side. I hope you understood. So I have actually told you this example. Let me define once again. So positive means true positive means observation is positive and is predicted to be positive. Observation is positive but predicted is negative is false negative. Observation is negative but predicted is positive and predicted is negative, then true negative. Observation is negative but predicted positive, then false positive. For easy purpose, let me teach you. So whatever you predicted comes in the right hand side. What about what you predicted? And if it is true or false, the predicted is true or false comes in the left hand side based on actual and predicted values. Okay, I hope understood. So now let's come to classification rate or accuracy. So accuracy is nothing but how many times you have predicted true, negative, and true positive correctly divided by total amount of predictions. Okay, that is accuracy. We have seen that. So recall is nothing but recall is true positive and true positive by false negative. Like whatever you have predicted, how many times the positive cases are predicted correctly. How many times the positive cases are predicted correctly is recall. Okay, and precision is when you predict positive cases, how many times that is correct. Okay, you have to understand Recall is how many times you have predicted the positive cases correctly. That's why we write true positive divided by true positive plus false negative, because you have predicted negative but it was positive. That's why how many times you have predicted positive cases correctly is recall, and the number of times you predicted positive cases, how many times it is correct. Okay, like you have predicted totally this many times positive cases, and here they have predicted how many positive cases you predicted correctly here, and whenever you have predicted positive cases, how many times it's correct. It's this precision. Okay? I hope you understood this concept. Next, come to FN score is nothing but harmonic mean of precision and recall. If you take this recall over here and precision over here, both gets multiplied and goes to numerator. So it will come to into recall by recall plus precision. So if you want the theory part, let me explain that as well. Since we have to measure precision and recall, it helps us to have a measurement that represents both of them. We calculate an F1 measure which use harmonic mean in place of arithmetic mean, as it punishes the extreme values more. So specificity. So okay, let's come to see specificity concept. So percentage of negative instances out of the total actual negative instances. So the specificity is nothing but total in the total negative instances, how many times you have predicted the negative instances correctly. Okay. This is specificity, 2 negative by 2 negative plus false positive. So this is all about the concept of confusion matrix. So let's come to my notes part. So let me take an example of here. The if let me say that there are actual positive cases over here as 18. This is true positive here. Predicted is positive, actual is positive. Now here it is 3. That is, what is this? Predicted is positive, actual is negative. That is false positive, because predicted is positive. Positive comes in the right. False positive. So false positive is 3 and false negative is 2 and true negative is 12. Okay. So what's the accuracy? You see, accuracy is total correct prediction. 18 plus 12 divided by total number of prediction. 18 plus 12 plus 3 plus 2. That's 35. Total is 80, 30, 35. That's the accuracy. Misclassification is 1 minus 30 by 35. That is 5 by 35. 3 plus 2, 5 by 35. And if you want the precision and recall, so let me consider precision first. Precision is nothing but whatever you have predicted, how many times that you have predicted the positive cases correctly. Is it? It's the same, right? Precision is nothing but how many times you have predicted the positive cases correctly. That is 2 positive by 2 positive plus false positive. True positive is 18 divided by 18 plus false positive 33. 18 plus 3, 21. 18 by 21. And recall is 18 by 18 plus 20. 18 plus 2, 20. So 18 by 21 is the precision, 18 by 20 is the recall. Recall is the thing, but how many times you have predicted. So whatever prediction you have made, how many times, so whatever prediction you have made, how many times you have predicted the positive cases correctly is the recall. Also, the recall is nothing but how many times you are able to predict the positive cases correctly. Positive. So this is 2, negative is predict is 2. So I hope you understood this. So let's come to the concept. True positive is predicting positive cases correctly. True negative is predicting negative cases correctly. False positive is predicting negative cases incorrectly. False negative is predicting positive cases incorrectly. So accuracy you have seen, this classification also you have seen. True positive rate you have seen, positive by total actual to positive. True negative, false positive rate I have seen, actual negative. True negative you have seen, false negative you have seen, and precision you have seen when it is predicted how often it is correct. Okay, understand this. Precision is when it is predicted positive, how often it is correct. That is precision. And how many times you have predicted the positive cases correctly is the recall. Okay, so formula for precision is this, and formula for precision recall is this. Okay, you just need to understand the concept. You will be able to write the formula on your own if you don't have to remember these formulas alone. Precision is total predicted positive, recall is total actual positive. So let's see the difference between precision and recall. So we know in the denominator here it comes false positive because we are predicting how many times you have predicted positive correctly, or is it like that? How often it is correctly, that is precision. And in recall, we'll find out. So how many positive cases you have predicted correctly. Use precision when false positive is a higher concern, because when false positive is higher, then this value decreases and your precision score becomes less. So you need to have a high precision score. And similarly, use recall when false negative is higher concern than false positive. So this example for precision is email spam or not. Not spam email are predicted spam, which are important. Then that is false positive. And actual transaction happened is fraud and predicted not fraud. That is also kind of false negative. F1 score is harmonic mean of precision and recall. So F1 score is 2 by 1 by precision plus 1 by recall. So I have seen this in your 10th class only, harmonic mean. So combined approximation of both precision and recall is harmonic mean. So we have covered the concept of evaluation matrix, how we are going to evaluate our performance of the model that we have, our performance of a classification model. So now let's come to the concept called RSC curve. Okay. So ROC means receiver operating characteristics. This was initially used by operators of a military radar in 1941. That is why it is named ROC. ROC curve is a graph plotted between true positive rate and false positive rate. Okay. So let's discuss area under curve now. So the area under the curve is summary of ROC curve and is measure of classifier's ability to discriminate between classes, that is true positive rate and false positive rate. The higher the area, the between the and the higher the area, the better the performance of the model to distinguish between the positive and negative cases. Okay. So let's come to this PDF. So ROC stands for receiver operating characteristic, and the graph is plotted between true positive rate and false positive rate for various threshold values. As true positive rate increases, false positive rate also increases. Sorry, actually, as true positive rate increases, false positive rate decreases. ROC AUC is just the area under the curve. The higher its numerical value, the far better. So this is if this is let's take this is the ROC curve. So this is the decision boundary. So whatever if of ROC curve comes better over here, so area under the curve is higher, and if area under the curve is higher, then it's at the true positive rate will be higher as well. So when true positive rate is higher, then false positive rate will be lesser. So this is how the graph comes. I will show you in the Jupyter notebook. So let's see the theoretical concept. So this is not it, but so let's come to logistic regression ROC curve over here, the notes. So ROC curve is the curve between plotted between true positive rate and false positive rate. So this is the 50% for the ROC curve. The value, if the ROC curve comes like this, then area is lesser and more false positive rate. I mean, we can see the rate of false positive rate is higher and true positive rate will be lesser according to that. If our ROC curve comes like this, then area under the curve will be higher and true positive is close to true positive. So true positive rate will be higher as well. ROC curve is nothing but the plot between true positive rate and false positive rate. Area under the curve is plot area under the curve. We calculate using the ROC curve, that is the true positive rate versus positive rate. Area under curve we will calculate. Okay. ROC is a probabilistic curve. Okay. ROC is a probabilistic curve and it gives the probability of the true positive rate. What it tells, it gives the model classification capability. How your model is classifying true positive and false positive cases correctly. That it is what it tells. So our area under the curve tells how much of the time, how many times your model is able to predict between the of positive and negative cases correctly. If model is going to predict 0 as 0, 1 as 1, then it's a good model. If a model is predicting 0 as 1 and 1 as 0, then it's not a good model. So you have to see how many times, like what kind of percentage of, what is the area under the curve for the true positive rate and for positive rate to classify the model as a good model or not. What do you mean by area under curve is 70% or 0.7? So 70% of the chance that the model is able to predict, distinguish between positive and negative cases correctly. And 30% it is not able to predict correctly. This is what area under the curve 0.7 means. So we will do the programming part in the Jupyter notebook. You will understand it better when we do. So if your ROC curve comes like this, so area under the curve will be lesser. So then false positive rate will be higher. So your model is not a good model. If ROC curve comes like this, area under the curve will be higher, and model is a good model based on what kind of AOC, AAC score, area under the curve score you get. So we have another concept called area under curve of PR curve as well. You will see it in the coding part where the Jupyter notebook. Okay? So let's see some theoretical concepts. So assumptions of logistic regression. The outcome is a binary or dichotomous variable like yes or no, positive or negative, 1 or 0. There is a linear relationship between logit of the outcome and each predictor variable. Recall that logit function is logit is equal to log of p by 1 minus p, where p is the probabilities of the outcome. There are no influential values in the continuous predictors. Extreme values or outliers. There are no high intercorrelation, that is multiplicity is not present among the predictors. These are the assumptions of a logistic regression. So we have constantly discussed this topic. So this is the end of the session. I have completed logistic regression. So in the next session, I'm going to take the coding part. Let's see, let's take a CSV file and do some log predictions on that. So see you till then. Bye.